Okay, good morning, Professor David J. De Los Reyes. Okay, happy Independence Day. Okay, it's July 4. No, it's already July 5. We just finished the Independence Day. We had the firecracker firing a while ago. Okay, my topic for this morning will be it's another random topic under integral calculus. Oh, we are saturated with algebra. Okay. We'll go integral calculus. Oh, actually, I finished already the integral calculus long video format. Okay, I got around 50 discussions. So this will be an additional, this will be a random, what you call this, long video format lecture. It will be added on my playlist under the title Summations of Algebra, Trigo, and other things. Okay. Okay, let's proceed. The topic for this morning will be evaluation of integrals, and this involves powers of trigonometric functions. Oh, I think I have given this one already under the short video form, but I was not satisfied because the time limit is just 60 seconds maximum, and I want to explain this one in a full video format. Okay, let's proceed. The given problem is evaluate the integral secant cube of theta, differential theta, and what will be the value. Powers of trigonometric function, and this involves a secant function, and the power of that secant is actually to the third power, differential theta. Okay, let's try to bring out the solution. If we try to manipulate, okay, this now involves what you call this, what laws this one under algebra? It will be commutative. I think it's associative. This can be written as, okay, we change this, what you call this, the one in the group. So it will be something like secant of theta. We can write this one as secant of theta, and the product secant square of theta differential theta. We change the, what you call this, the grouping, all right? So we segregate one secant of theta, and the other grouping is actually secant square of theta differential theta. It will be something like this. So if you try to observe it, we can place this one as our U and this one as our dB. Okay, so after the algebraic manipulation using the so-called associative law, right? We let the first one to be U, and the product of secant square theta differential theta as dB. So I am thinking of the solution integration by parts. This is integration by parts. Okay. Let's try to verify, and we shall test if we could actually evaluate the integral of b du. Because if this falls under the integral of u dv, it should be ub minus the integral of b du. I haven't explained this one yet, right? Just pray that we could evaluate the integral of b du. Because if we assume that this is under integration by parts, but if the resulting evaluation of the integral of b du will be very, very hard, okay, I think it will not be the proper solution. But if we could bring out the solution by evaluating the integral of b du, okay, thanks God, right? Okay, let's proceed with the solution. if we assume that this falls under the integral of u dv, so it should be ub minus the integral of b du. So we must have to compute for the value of u, for the value of b, and again the value of b, substitute the value of b times the value of du, then try to integrate. Just pray that we could integrate this portion here. Okay, let's proceed. I let u to be equal to secant of theta, this one, by using the associative law, right? I change the order, right? Taking the differential of u will be, the differential of secant will be a secant theta tangent theta times differential theta. The differential of a secant is secant tangent. So this will be secant theta tangent theta differential theta. That's differential calculus. Right? So we are now through with the algebra portion. We segregate this one, we change the order. Okay? So in here, we are now differentiating. How come we are differentiating in the problem is integral calculus? In integral calculus, you are performing algebra, you are performing differentiation, so it all matters, right? Okay? I will let db next one to be secant square of theta, differential theta, this one. If I will try to compute for b, I must have to integrate both sides, right? So I place it here, integrate. It should be both sides. We minimize writing, right? Integrating meaning it should be the left and right? So integrating, the integral of db should be equal to the integral of secant square of theta, differential theta. The integral of the differential of b is just b. When the integral sign comes this near the differential sign, they will try to cancel out each other. Right? So what comes out on the left will be b. Right? And the right hand side, we will still rewrite it. It will be the integral of secant square of theta, differential theta. But what is the integral of secant square of theta, differential theta? What function that when we will take the differential, it will be secant square of theta? It is tangent. Right? The differential or the differential or derivative of a tangent is actually secant square of theta. So if you try to integrate this one, the answer should be tangent of theta. It's the reverse operation, right? How could we know that this is correct? If you try to differentiate this one, the differential of tangent is secant square, right? So the integral of secant square of theta will be tangent of theta. It's just the reverse operation. Okay, I will try to check my camera. Oh, it's fine. Okay, I will continue now. I will be rewriting the original problem. Okay, by using the associative law, I change the order. It will be the integral of secant theta times the quantity secant square of theta, differential theta. As I have said a while ago, this will be my u, this one. This should be my db. Okay, and if we now try to recall the formula under the so-called integration by parts, the integral of u db, which is this, is equal to uv minus the integral of d du. So this is actually the so-called formula of integration by parts. Okay. Okay, let's try to substitute values now. What is u? U is secant of theta. And what is b? It is tangent of theta. I'm following this. Minus the integral of what is b? It is tangent of theta. And what is du? Secant theta, tangent theta, differential theta. Secant tangent differential theta. If we try to expand this one, it will be a secant of theta. I write first the secant of theta. A tangent and a tangent will be, oh, that's algebra already. You're multiplying two terms, okay? So it will be that same base tangent of theta, okay? times tangent of theta, so this is to the second power. Okay? Differential theta. Oh, that's algebra. Right? You are not only multiplying x times x, because x times x is x squared, but a tangent of theta times tangent of theta is tangent square of theta. And the proper way how to write this one is will be tangent square of theta. Meaning, it is the product of tangent of theta and tangent of theta. Laws of exponent. This is to the first power, this is to the second power, so it will be same base plus the sum of the exponent, which is 1 plus 1 will be 2. So, if we try to multiply this one, this will become like this. Right? Then, the first one, it will be secant of theta. Then, I will try to replace what's the equivalent of tangent square of theta. 1 plus tangent square of theta is equal to secant square of theta. We go back to trigonometry. This is identities already. 1 plus tangent square of theta will be equal to secant square of theta. So solving for tangent square of theta, we transpose this to the right. Or if you use your pre-algebra, you minus 1 here, you minus 1 here, so this cancels, right? So it will be secant square of theta minus 1, right? You can use your pre-algebra or just simply the automatic transposition. If you transpose this positive 1 to the right, it will become minus, so it seems it's just like that, right? Or if you want to show, it will be minus 1 plus e plus 1, so this cancels. So tangent square of theta will be secant square of theta minus 1. That's pre-algebra, algebra, it's the same, right? So going back to the problem, secant theta, tangent theta, it's just this, minus the integral, secant theta. We replace that tangent square of theta by secant square of theta minus 1, close quantity, times differential theta. Okay? We expand this one. This is preceded by negative sign, right? So a secant and a secant will be secant cube. Again, it's algebra. The product of secant of theta times secant square of theta. Okay? This is to the first, right? You're multiplying two terms. So it's again pre-algebra or algebra. It will be that same base, secant of theta, plus the sum of the exponent, that will be 1 plus 2, that will be 3. So the product of secant of theta times secant square of theta differential theta will be secant cube of theta differential theta. Right? To the third power. This is a minus and this is a minus. Right? So it will become plus. So it will be plus the integral. The only term is secant of theta differential theta. Okay? Okay, let's try to minimize some writing. This term here is same as this one, right? We put it on the left, right? So secant cube of theta plus this, it will become 2, right? That is after transposition. What remains on the right will be secant of theta, tangent of theta, plus the integral of secant. Okay? And the proper way on how to integrate is secant will be by multiplying the, what you call this, secant of theta by the quantity secant of theta plus tangent of theta close quantity. Because a secant of theta plus tangent of theta all over this is actually they cancel out, right? But we could place it, right? So if we try to, it should not cancel out because we place it, right? If we try to multiply the numerator, it will be secant square of theta times secant theta tangent theta. And the denominator will be secant of theta plus tangent of theta. I assume that this should fall under the natural logarithm. Let's try to verify. Okay. this is similar to the form the integral of a du over u, and the answer is actually the natural logarithm of u, okay, plus c, right? So let's try to verify the value of u if it is really the u. The u is actually the denominator, right? So u is actually secant theta plus tangent of theta. Taking the differential of u will be du. The differential of secant is secant tangent, right? So secant theta plus tangent of theta, differential theta. And the differential of tangent is secant square. So this will be plus secant square of theta. The common term is actually the differential theta. So if we try to observe this one, it is same as this. Same. So as per verification, after taking the differential, we have known that the complete differential is exactly the given numerator. So the solution of this will be the natural logarithm of u plus c. So the total solution now, okay? We got ito here a while ago, but the problem is only asking for secant cube of theta differential theta. So we will multiply the only terms by 1/2. So this is multiplied by 1/2 also. So 2 secant cube theta differential theta multiplied by 1/2. These two here cancel with this. What remains will just be simply secant cube of theta, right? So this is gone, right? It's the problem we are asking, right? So these two here now will be multiplied to the total value of the right hand side. It will be 1/2. Well, I will get the first one. I will multiply by secant theta plus tangent of theta close quantity plus 1/2. The integral of this is a natural logarithm of u. The natural logarithm of this. The natural logarithm of the quantity secant theta plus tangent of theta close quantity. This is plus c. Okay? Oh, that's it. Okay, that will be our answer. There was ito here a while ago, so to compute only for this, we will multiply all the terms by 1/2. Yeah, 1/2. So this will be gone, right? But there is 1/2 on the right hand side. This is 1/2, this 1/2. So the final answer now will be the integral of secant cube of theta, differential theta will be 1/2. Secant theta plus tangent, secant theta tangent of theta, okay, plus 1/2, the natural logarithm, the integral of secant of theta, as per verification, is the natural logarithm of this one, the natural logarithm of secant theta plus tangent of theta close quantity, this plus it. That's it. So for those of you who are taking up what they call this integral calculus, these are for you guys. If you want to subscribe to my channel is at youtube.com/@ProfDavidJ. If you want to share it, please click share. I hope you understand my explanation. Good morning from Los Angeles.